When we solve trig equations, you want to keep in mind that the answer to any trig equation is an angle measure. Just bring this back over. So the answer to any trig equation is an angle measure. What we do in solving trig equations, we try to rewrite everything as a single trig function. So that requires you to use the formulas previous in this section to simplify. Once you simplify your trig function, you'll then solve the trig function. And we're going to look at two methods to solve, or actually we'll look at three. There is something called a linear method to solve a trig equation. There's something called a quadratic method to solve a trig equation. And we could also use a calculator. All right, but before we begin any of that, I want to show you that you can factor trig functions. And here's what I mean by that. Okay, and I believe my pen is going dead. We're going to take a look at factoring as it relates to algebra. Okay, and then we're going to evolve up to trig functions. And I'm trying to make my pen a little bit thicker. Okay, how are you supposed to do this? All right, so we're just going to look at factoring. So let's say you were asked to factor x. Let's say that you were asked to factor x squared and I thought it was a way I could make this actually darker. X squared plus five x plus 6, right? And let's say you were asked to factor x squared plus 5x plus 6. So we're going to factor, we're going to make two sets of parentheses. Just keep in mind whatever you put as your first terms, right, you must be able to multiply and get the first term in your trinomial. Remember that factoring and the FOIL method are like reverse processes, right? So if I were to go back and FOIL this together, x times x is x squared. The next thing you want to do is determine your signs. So when you determine signs, see x squared plus x plus c, and I have no idea what's going on with my pen. X squared minus x plus c, x squared plus x minus c, and x squared minus x minus c. All right, so basically these would be your setups, and I have all the different possible combinations. And this is how you determine your signs. All right, so like for each one of these things, you're going to have x, right? Because when you multiply the first terms, you must get the first term in your polynomial. When you determine signs, okay, this is how this works. If your last term is positive then both of your numbers are going to have the same sign as your middle term. Right? So since this last term is positive and my middle number is positive, both of the signs are going to be positive. If I look at the second scenario, my last term is positive, so that means that both of the numbers are going to have the same sign as the middle sign. Therefore, both of these numbers are negative. Right, so in a nutshell, if your last term is positive, you're going to have both of the numbers you're using are going to have the same sign as the middle term. However, if your last term is negative, right, like in these last two setups, it does not matter what the sign of your middle term is. One of the numbers is always positive and one of the numbers is always negative. Right? And this is how you should determine signs. So now just by knowing that, looking back at our example, the last term is positive, the middle term is positive, so we know that both of our numbers are positive. Now we're going to use something called a product sum. Right? We need two numbers, both are positive, whose product is equal to 6. Right? So the product always equals to the last term, and the sum is equal to the middle term, which is 5. So now if we look at the factors of 6, okay, you can get 6 by 1 times 6, but if you add 1 plus 6, you get 7, which is not a 5, so 1 and 6 are not the factors. We can use 2 times 3, right? 2 times 3 is 6, 2 plus 3 is 5, so the numbers we are to use are 2 and 3, right? I can go back and actually check my factorization by using the FOIL method. Right. So that means if I take x plus 2 times x plus 3, and if I were to multiply those together, I should get x squared plus 5x plus 6. All right, so I'm going to FOIL that out. So I multiply my first terms, x times x is x squared. I can multiply my outermost terms, 3 times x is 3x. I can multiply my innermost terms, 2 times x is 2x. And I can multiply my last terms, right? A positive times a positive is a positive. 2 times 3 is 6. And if I combine like terms, I have x squared plus 5x plus 6. Right? You can do the same thing for trig functions. All right, so here's an example. We're asked to factor and give me 1 second. We're going to factor 2x squared minus x, 2 cosine squared x minus cosine x minus 1. All right. So we're going to factor 2 cosine squared x minus cosine x minus 1. All right, so we're going to factor pretty much the same way that we factor in algebra. So I'm going to count it really well. All right, so I'm going to make 2 sets of parentheses. What I put as my first terms, I must multiply and be able to get 2 cosine squared x. Right, so I'm going to multiply 2 cosine x times another cosine x. Right, because 2 cosine x times cosine x is 2 cosine squared x. Right, I get my first term. Now I have to determine my sines. Okay, and here's where a little bit of trial and error comes in. Or trial and check, I should say. Since my last term is negative, I know that one of my numbers should be positive and one of my numbers should be negative. Right? So I have to, this is called a trial and check. So I'm going to make the first term negative and I'm going to make the first term positive and the second term negative. Whatever I put as my last terms, I must be able to get a -1. And I must also be able to get a sum of 1. All right. So for this instance, I'm just going to put in a 1 and a 1. Right. I'm just going to check this out to see if I get, in fact, I get what I need. Right. So if we were to use a FOIL method, 2 cosine x times cosine x, that's 2 cosine squared x. If I take my outermost terms, 2 cosine x times -1 is -2 cosine x. If I multiply my innermost terms, 1 times cosine x is cosine x. And if I multiply my last terms, a positive times a negative is a negative, and 1 times 1 is 1. And now I will combine like terms. Right, so I'm going to bring down my two cosine squared x. -2 cosine x plus cosine x gives me negative cosine x minus 1. Right, so I know that this is the correct factorization. Now we'll see why in a second it's important to be able to factor quadratic equation. To factor trig equations. All right, so we can factor them. There are two methods that we're going to use in this course. One is called a linear method. Now keep in mind this was taken from a different textbook. All right, so the information is a little bit different, but it's pertinent to this course. So this says solve a trigonometric equation by linear methods. Right, and we're going to talk about what a linear method is. And then this says solve a trigonometric equation by a quadratic method. Right, so what is a linear method and what is a quadratic method? All right, and to explain, I'm sort of going to go back to algebra first before we actually jump into the trig part of things. So here we have a linear equation. So solve the linear equation. Two x minus 1 is equal to 6. Or make this 5 just to keep everything nice. All right, now what makes this a linear equation? Well, what makes this a linear equation is that my variables have no power past the first power. All right. So notice I have the only variable here is x, and x is raised to the first power. So that makes this a linear equation. Okay, on the next instance, we're going to solve a quadratic equation. So let's say we have x squared plus 5x is equal to negative 6. Right? This is a quadratic equation because the highest power is a square. Right? So that would be a quadratic equation. Now, the way you solve these things are totally different. In order to solve the linear equation, we must isolate the variable. Okay, so what does that mean? That means that we must put the variable on one side, we put everything else on the other side, and then we can solve. So here's the linear method. In order to solve 2x minus 1 is equal to 5, the first thing I'm going to do is add 1 to both sides. So I have 2x is equal to 6. In order to isolate the variable x by itself, the opposite of multiplying x by 2 is to divide by 2. Right, so I'm going to divide both sides by 2. And if I divide both sides by 2, I have x is equal to 3. Right. Now I can check my solution. Right. In order to check, and this is true of trig functions, in order to check your solution, you go back to your original problem. Right. 2x minus 1 is equal to 5. And we're going to substitute x for 3. If x is the solution, it's the magic number that'll make both sides equal to each other. All right, so wherever I see an x, I'm going to substitute a 3. All right, 2 times 3 is 6. 6 minus 1 is 5, so 5 is equal to 5. Right. So that is a linear method. The linear method means you must isolate. First off, you must have a linear equation. A linear equation means that the variable or the trig function is raised to the first power. Here is a quadratic method. In order to solve a quadratic equation, you must first put the equation in standard form. Right? So standard form just means that you have to set it equal to 0. So set equal to 0. And then you want to solve. Right? So remember, when you're solving quadratic equations, there were a couple of different methods. Right? You could factor and use the zero factor property. Right? And this should always be your first mode of operation. I don't know if my pen is dying or what, but factor and cancel should be your first mode of operation. Then you could use the quadratic formula. Right. These are the only two methods that I would use when solving trig equations. All right, now you could use like complete the square and what else that? The square root property, right? Well, I should put that square root property. Okay, these are the three methods that you should use, right? I wouldn't use complete the square. Okay, but the factor and cancel pops up, the square root property pops up, and then in some instances the quadratic formula pops up. All right, so let's take a look at solving this equation. All right, so first thing we got to notice is that it's quadratic because we have a power of 2. All right, the largest degree or the largest power is 2. So we're going to put it in standard form, which means we're going to set it equal to 0. So I'm going to add 6 to both sides. Right. Now I'm going to factor. Right, so we factored this earlier, so we have x and x. All right, it's still set equal to 0. My two numbers are positive. The two numbers I'm going to use are 2 and 3. The zero factor property I'm going to write that over here. The zero factor property says if A times B is equal to 0, right? So notice that's a product. That's A times B, right? I have two factors. A is my first factor, B is my second factor. Then you can take each factor and set equal to 0. Right? So if A times B equal to 0, then you can take A equal to 0 and you can set B equal to 0. Right? So that's what I'm going to do here. And in this instance, A is going to be x plus 2 and B is going to be x plus 3. So I have x plus 2 equal to 0, x plus 3 equal to 0. Right? And these things are now linear equations, right? Because the squares disappeared since we factored. And in order to solve, we're going to isolate. So x is equal to -2 or -3. Here again, you can check your solutions. So in order to check, we can only check one solution at a time. Right? So we're going to go back to our original equation. X squared plus 5x is equal to -6. We're going to substitute in -2 for x. Right, so we have -2 squared plus 5 times -2. That should equal to -6. So -2 squared is 4. 5 times a -2 is -10. And we have both sides equal. Right. Now I'm going to bypass -3, but -3 should also check out. Right. Both of these things are solutions. All right, so now we'll take a look at, I guess, one example. All right, and it's this one. It says solve the trig equation. We have solve 2 sine x minus 1 is equal to 0 over the interval from 0 to 2 pi. So we want to solve 2 sine x minus 1 is equal to 0. Yeah, 2 sine x minus 1 equal to 0. All right. So the first thing you should notice is that this is a linear equation, right? Because I have the sine of x, and that sine is raised to the first power. Right? Now, if this were like 2 sine squared x minus 1, that would throw it into the realm of being a quadratic equation. Right? So if you have a square, you treat it as a quadratic. If you don't have any powers, then it's a linear equation. It's a linear trig equation. So in order to solve it, we're going to isolate for the sine of x. Right? So in order to isolate the sine of x, right, I'm going to add 1 to both sides, and I'm going to divide by 2. So the sine of x is equal to 1/2. So now there's something in the directions that is very important. It says solve 2 sine x minus 1 is equal to 0 over the interval from 0 to 2 pi. So solve in the interval from 0 to 2 pi, right? So what does that mean? Well, we're going to interpret this as what angle in the interval from 0 to 2 pi has a sine or y value, right? Remember, the sine is the y value of 1/2. Okay, so now keep in mind, these are not inverse functions. Okay, inverse functions were something totally different, right? We're looking at all of these things in the interval from 0 to 2 pi. So I'm going to pull out my unit circle, right? So we're going to completely around the unit circle. We're looking for all angles that have a y value of 1/2. So I see that 30 degrees or pi over 6 has a sine value of 1/2. And also 5 pi over 6 has a sine value of positive 1/2. So my two angle measures here are pi over 6 and 5 pi over 6. Right, so the angle x that we want are pi over 6 and 5 pi over 6. All right, so we have pi over 6 and 5 pi over 6.